Hi class, Mr. Morris again, and we're continuing talking about stoichiometry. Today we're talking about mass stoichiometry. There's a couple things I want to make sure that I emphasize at the very beginning. It's really, really important that you understand that chemical equations are written in terms of moles of reactants and products. Now you may remember that we sometimes talk about it in terms of particles, individual particles, atoms, and molecules. That's true too. But remember that a mole is just a number, so if it's a number of particles, like a mole is, we can do that. But what we can't do is assume that the chemical reaction is balanced in terms of mass or volume or anything like that. So that's kind of the foundation of what we're talking about today, and we're going to get started off just talking about mass stoichiometry. Keep in mind, in experiments, we have a lot of different tools we can use to measure the products that are produced. So this is how it works in the real world. For solid reactants and products, we could use a balance and measure the mass in units of grams. For liquids, we could go get a graduated cylinder and we could measure the volume. And the units of volume with a graduated cylinder are normally milliliters. So we can measure the mass of a solid, the volume of a liquid. For a gas, we could measure the volume of a gas too. There's ways that we can do that. But we can get a barometer or a manometer. Those are instruments that measure the pressure, and we could maybe use units of atmospheres, ATM. By the way, you're probably not familiar with that unit yet. Don't worry, we'll get to it later when we talk about gases. Unfortunately, there is no equipment. There's not a piece of equipment that exists that can be used to measure the amount of reactants and reactants and products in units of moles. We can't measure moles. There's no mole meter. So because there's no mole meter, we need to be really good at conversion. So that's where the molar mass comes in very, very handy. Okay. When you're given mass of reactants or products in grams in the problem, we have to convert the given masses to moles before we continue with the problem. And when you're asked for mass of reactants or products in grams, we have to convert the calculated mass, moles to masses to answer the question. So again, if you're given mass of reactants or products, we have to convert to moles. But if we're asked for mass, then we're going to find what we're looking for in moles and convert the calculated moles into mass in grams. And how do we do that? How do we convert between grams and moles? I hope that you remember it, but just in case, we're going to use the molar mass of the substance. And use dimensional analysis. Dimensional analysis, again, is that method that we use, that you'll be given some number of grams, and we put the molar mass in grams on the bottom, 1 mole on top, and we can calculate it. Or if I'm given a number of moles and I'm looking for grams, I'm going to cancel out the moles, put 1 mole on the bottom, and put our molar mass as the number of grams on top. Okay, that's dimensional analysis. That's what I mean by dimensional analysis. So find the number of moles. This is our general steps to solve a stoichiometry problem. And by the way, this will work for the rest of the year. And yes, stoichiometry is here to stay. We're going to be using this all year long. In every unit, we'll talk about it a little bit in terms of something. Okay, so find the number of moles of the given. That's our first step. If you know we're doing a stoichiometry problem, find the number of moles of the given. Solve for the moles of the substance that are asked for. That's just like what we learned in our mole stoichiometry notes. So if you need a refresher, look back at that. And then convert your answer to the units that are asked for in the question. So convert using dimensional analysis to the units that are asked for. normally using dimensional analysis. Later we'll talk about something a little different, but this is our process. Find the moles of the given, solve for moles of what's asked for, and then convert your answer to the units that are asked for in the question. Problems with given volumes of reactants are going to be tackled in later units, gas stoichiometry and solution stoichiometry. So as I said, this will come back. You're going to want to remember these 3 steps in terms of not just mass, but later volume, pressure, and other things. All right, we are going to do an example problem next.